So we got a really kind of diverse set of skills here: MEP engineer, architect, 2 builders, and a green building subject matter expert. So I think we'll have a lot of different perspectives. As a brief intro, we're going to focus on New Jersey Energy Code specifically today a little bit, but we're going to also be discussing the 2015 Energy Code in general, which has obviously just been adopted also in New York. And even for those in Delaware too, I mean, the 2012 code is much similar to the 2015, that is the 2009. So this we'll kind of zero in on some New Jersey specific stuff as we go through, but we'll also speak broadly, so if anyone's here from out of state, this will also be applicable. Speaking of kind of out of state, this is kind of the whole reason why we're here, right? Over the past 3 years, basically up and down the coast, you've seen every state that basically borders the Atlantic Ocean adopt a new energy code over the past 3 years. So I think that graphic kind of speaks for itself. This has obviously been a big transformation we've all experienced, and I'm sure many of you can speak to that personally, and it's only really going to continue. So first we're going to talk about the permit application stage, then we'll kind of go sequentially through the different inspections, and then we'll talk about kind of what happens at the end in occupancy. The compliance certificate is, for all intents and purposes, largely an afterthought, so we won't focus on it too much. In New Jersey, there are actually 5 ways that you can permit. 4 of them are in the 2015 IECC, which is the base model code that New Jersey adopted to be its energy code. And one of them, if you do Energy Star through the New Jersey Clean Energy Program, that is also an acceptable means of energy code compliance in New Jersey specifically. Prescriptive is exactly what it sounds. You follow all prescriptive requirements and the specified insulation values in the code tables. UA Tradeoff, which is, I'm sure many of you are familiar with, it is typically done through a res check, but it's just a weighted average insulation value calculation, and you're still subject to all prescriptive requirements except when it comes to insulation values where you can trade off. The performance pathway, you're complying based on your projected energy costs, so the metric isn't your overall UA value, the metric of compliance is your projected energy bills. And there's a little bit more than insulation that factors into that calculation. It's still not taking into account every efficiency in the home and trading it off, but it is more of a dynamic kind of analysis than the UA trade-off. So sometimes if you have certain efficiencies outside of insulation, the performance pathway kind of helps you get credit for them. The energy rating index pathway is new to the 2015 IECC. We're not going to dwell on it kind of a lot today. You remember we mentioned HERS as a system. So when you do a HERS rating and you go through the process, which we'll talk about, one of the outputs of that is the HERS index score. And you can actually permit based on that HERS index score, so that as your metric of code compliance. But it's kind of intentionally over-designed in the current version of the code because they were a little bit conservative the first time it was going in. So it's not really a very cost-effective option at present, but that could change in the 2018 code. And then Energy Star, as I mentioned, I think many of you are probably familiar with that certification program. If you go through the rebate program in New Jersey that incentivizes you to do Energy Star, that satisfies code in and of itself. This is just kind of a brief summary, and we'll kind of come back to a lot of these points. I'm not going to go through them, of kind of the relative benefits of each pathway. Energy Star and actually the HERS index pathway, you do get rebates for. There's basically, as you go down the chart, you have increased design flexibility, so you're allowed to trade off more things.
With regards to multifamily and townhouse, we have no choice, in my opinion, but to go the Energy Star pathway. To hit the 3 air exchange rate on a slab on grade townhouse or multifamily is extremely difficult. And I don't even think you can do it with a multifamily.
We're not using the prescriptive path ever. We are using either the total UA, res check, or the performance path. In New Jersey, we tend to use more the total UA and the Energy Star program, which is very unique to New Jersey. For the majority of builders, this visual inspection is the path that they're going, and the Energy Star program in New Jersey allows that. We're not using the ERI path at this moment because it is too far. It's about 10% more efficient than the prescriptive code is to start with. The ERI path is going to become more relevant.
Part of the decision of how you permit has to do with the relative inspection thresholds that are associated with each pathway. So the 3 air change per hour we'll get into when we go through the air sealing section. But this is really kind of a new concept, whereas the way you decide to design your home and permit home actually affects your inspection requirements. And I think that's kind of a new kind of invention. A lot of times you just kind of got your res check, and then the township did whatever the township would do, and you were set. Now it's really important, and this is why we really feel that architects are well supported working with energy code experts, because they have to understand the implications for the construction team when you're making decisions even in the design stage.
First, I'd like to say a lot of the requirements kind of set up initially before we get to the point of design as a mechanical engineer, meaning the structural engineer would determine the exterior wall is a 2x6, so then by default it would be an R21 bat. So a lot of these parameters have been decided initially before we get to the point of the analysis. But I want to make a comment about the UA, and Rich and I talked about this.
Yeah.
There's not much flexibility with the UA anymore, meaning years ago we were able to mess around with the window quantities, the attic insulation. 2015 code doesn't really have much flexibility. It's R21 wall, put in the attic at 49 and it's passing.
Now that the code is so advanced, the UA Tradeoff Pathway, its kind of rigidity can be really challenging, and you could end up incurring a lot of cost if you don't explore other alternative permit pathways as a potentially more cost-effective solution.
In past years, previous versions of the code offered a lot of flexibility, a lot of choices in terms of what we can do. So typically, we use the res check.
Yeah.
Res check requirements used to have a huge advantage over prescriptive. Because if you went through the res check process, you find you could reduce your wall insulation, for example. You could still build 2x4 walls with R13 bat by using a trade-off, either within the mechanical system or by increasing the amount of insulation in the attic. Well, as the prescriptive requirements have gone up, as the codes have evolved, and the res check has gotten more restrictive, those trade-offs are less and less.
The idea of using Energy Star as a code compliance pathway, and the fact that it is, as Dean said, it's a unique New Jersey ability. If you do Energy Star in other states, that doesn't exempt you from also meeting, any mandatory code requirements. In New Jersey, it does.
Energy Star doesn't have a set blower door requirement. As long as you meet the Energy Star HERS target threshold, then that's one of the main requirements for Energy Star. The difference in Energy Star versus the rest of the code is that you also have to meet all of the additional Energy Star prerequisites that are above and beyond the current code. They have ventilation requirements for bathrooms as well as kitchens that are also getting measured and verified, where although the code does require ventilation in bathrooms, and I believe in kitchens as well, it's not actually getting verified so much in the code, where in Energy Star it's a prerequisite and that it can be a pass or fail because of that.
It's not actually Energy Star certification, it's going through the New Jersey Clean Energy Program, which incentivizes all sorts of energy efficiency and renewable energy. And when it comes to residential new construction, they use the Energy Star standard as what you have to do to get a rebate. But when you go through that process, you're submitting documentation to them, they're doing quality assurance oversight on you. So there's a state agency in New Jersey that essentially you're under their purview to show that you are meeting a certification program, Energy Star, that is designed by the EPA to exceed code by 15% roughly or so. A lot of these states, the IECC is the model code, but then states make minor amendments to the code when they adopt them, and that has really significant implications, right?
We're focusing a lot right now on verification testing.
Yeah.
The code does give you the pathway of the visual inspection. Okay, that's one of the options. It's a very scary option in my world and for most national builders, because basically, and it's confusing amongst the building inspectors as well. The code's written very ambiguous in my opinion. So you can actually have your local inspector fill out the checklist, and then he may ask you as a builder to sign it or another representative. And if you've met the intent of the code and the standards for air sealing, you don't have to do a blower door test. You still have to do a duct test. But it sure opens up a can of worms in my mind about whether somebody comes in and tests after the fact. You don't hit that 3 air exchange target. With the national builders that I've been with, we've stayed away from that pathway. But there are a lot of smaller builders, single-family home builders, that are taking that path.
So what happens if I do a visual inspection on a home pick a single-family home, somebody moves into it, 2 years later, they're selling their home, and they have a rater come in and do a blower door test, and the thing blows at 6. I did a visual inspection saying it was 3. What kind of liability do I have? It scares the heck out of me, of the notion of doing visual inspections. It's very risky not to do blower door tests.
The only reason I can guess that they did this was to try to give the builders some slack. They thought they were making it easier and potentially less confusing. The other interesting part about the code is it's written for renovations and rehabs as well. So my kind of thinking on this is that, you know, if you're just renovating just a bathroom or a kitchen, you can't do a blower door test on that one little spot. So in order to kind of meet the intent of the code, you know, I think that might have been kind of written in. So in other states, they give exemptions for, you know, rehabs and that, but that's a separate addition to the code that the state's writing, where New Jersey can't really do that.
This is basically across the states, New Jersey, tri-state area, and Delaware, what the requirement was under 2009 code, and now what it is under either 2012 or 2015 code. You can see Pennsylvania is the same because they're still on the 2009 code. In the model code, the IECC, for 2009, it said 7 air changes per hour, and you could verify it either with a blower door, or as Barry kind of talked about, the checklist. The air barrier items are just visual verification of certain, basically, air sealing measures. And the idea is that if you do those measures, that you would presume that the house, if tested, would achieve the equivalent, you know, air changes per hour with a blower door test. It wasn't kind of absurd on its face that you could visually verify and say it's 7 air changes per hour. But there's a reason that the model code didn't allow you to do a visual verification when it came to 3 air changes per hour, because it's just too difficult of a standard to visually verify. And so a lot of the other states came up with different ways, and I think Dean talked about this too. In Delaware, it's based on your square footage. I think if you're under 1,000 square feet, you're allowed up to 5 air changes per hour. Is that right?
I don't remember the exact number.
Something like that's like a tiered. And
There's a formula.
Exactly, yeah. And in New York, it's on attached. Any attached unit has a different standard because they recognize that these things were really difficult to achieve. As Barry said, maybe even impossible for certain building product types.
You know, we're talking a lot about going from 7 air exchanges to 3 air exchanges. You know, that's because we're pretty familiar with it. In my opinion, going from 7 air exchanges to 3 air exchanges is a quantum leap, okay? It's a massive undertaking. So, I mean, it's real important that we let you guys know who aren't familiar with those numbers that it's not just a little extra foaming and, you know, tightening a house up. It's a whole nother approach.
Whenever we're talking about air sealing, you really kind of have to decide where your primary air barrier is going to be for this blower door test. And the decision really is, do I make it at the exterior, or either at the sheathing outside of the insulation, or do I treat it at the sheet rock? And really the implication is apparent when you do the testing. So if there's any issues during testing, if your air sealing's at the sheathing, then it can be very difficult to make any corrections. But the advantage on that side is that there's less items to air seal. There's kind of less to go wrong. So it's a little more straightforward, but if you screw it up, it can be very difficult to fix. Treating the sheet rock as the air barrier might be difficult to fix if you're failing, but there are many, many penetrations, and when you start thinking about it, every electrical box is now a leakage point. And you can't just do the rough opening of that electrical box because there's all the knockouts. So it can be very difficult and time-consuming to really treat it that way. So that's kind of the two sides of this. And you know, probably the follow-up question is, what am I seeing most? It's probably treating the sheathing as the air barrier because it's a little more straightforward.
See the illustration on the top right? That's what we call topside seal. It's actually not a new theory. It's been around. I think it was involved in the Act of 22 in the old days as well. If you're now building under the 2015 IECC, you need to make that standard. Okay, that's part of your air sealing package. I don't care if it's single family, larger single family townhouse, that is now something you need to anticipate doing. Because that's probably the best bang for your buck, in my opinion, when it comes to air sealing.
Yeah, the issue is if you're using fiberglass bats in that sealing assembly,
Yeah,
you can't do it. There's no way to get to that area. So the alternative is to have your sheetrocker, as they install the sheetrock, seal this gap. And so what's done there is typically the ceiling is almost always installed first. So they install the ceiling as they normally would, and before they install the wall, they run a thick bead of caulk between the sheetrock and that top plate to seal this gap. The real issue is that it's very tough to verify that this was done unless you're watching these guys do it.
I just wanted to clarify that the UA and the prescriptive, that's just the insulation level. That's not the air leakage. So I don't know if there was some confusion there. The UA is only insulation, roof, wall, floor. The air leakage is a mandatory requirement. That's separate from the insulation.
Correct. So what John's speaking is that, and it's timely, we'll kind of move on to, we'll switch over to insulation in a second, but there are two types of requirements in the code. There are mandatory requirements, like the air sealing requirement of 3 air change per hour. And then there are prescriptive requirements in the code. Unless you go through the Energy Star program, you always have to have an insulation inspection done by the code official. So that doesn't change. They complete the items that are labeled I, and that's pretty much it. We'll go back to this at the end if we have time, but we want to get to duct sealing because that is a more challenging part of the code under the new code. So there's two types of duct leakage tests. There is a measurement of the total leakage of the home, and then there's a measurement of how much of that total leakage actually escapes to the outside of the home. So as sort of an illustrative example, imagine a home where all the ductwork is in conditioned space, and none of the ductwork is hooked up to the registers though. So it's crazy leakage, the total leakage is off the charts, but none of that air is escaping to the outside of the home. So the actual measurement of efficiency is duct leakage to outside. Right? You might have a comfort issue in the example I just gave, but you wouldn't have an efficiency issue. So the actual measurement, the duct leakage number that goes into the energy model, when you do your calculation for your performance pathway or for Energy Star, that is the duct leakage to outside. Total leakage is just the overall amount of leakage of the home. So it includes the leakage that's going to the outside, but it also includes a lot of the duct leakage that's staying inside the home. This is again from basically 2009 code to 2015 code. So under the 2009 code, didn't matter how you permitted, your duct leakage options were the same. You could either meet it based on that duct leakage to outside test, and you can only do a duct leakage to outside test at the final because there needs to be an outside, or you could do the total leakage test. And the standard for total leakage, if you did it at rough, was a little bit different than if you did it at final, but you had basically total optionality to test at any stage, and it was not affected in any way by how you permitted. In the new code version, if you go through the UA pathway, which is subject to the prescriptive requirements, you have to hit now 4% total leakage. That's it. There is no duct leakage to outside option if you go through those pathways, and it doesn't matter whether you're testing it rough or final. The standard's the same, so frankly, you might as well test it rough. And it's actually 3% total leakage if your air handler is installed at rough when you do that test. That is a really big jump, from basically 8% total leakage, 12% at the final under the 2009 code, all the way down to 4%. So it's definitely a big challenge. And again, you could have a system where your leakage to outside is very minimal, but it's frustrating because if your total leakage is in excess of 4, that's it. So when you go through the other pathways, the performance pathway, or the ERI pathway that we talked about, you're not subject to the prescriptive requirements. So you don't have to hit 4% total duct leakage. Your effective only duct leakage requirement is hitting whatever duct leakage to outside number that you say you're going to hit and we include in the energy model that's part of your overall calculation. So you can trade it off with anything else, right? More insulation means you can be allowed more duct leakage. So that's a dynamic kind of trade-off calculation that's done for that. And then for Energy Star does have required duct leakage thresholds, but Energy Star requires 4% outside and 8% total. So just think about that for a second. Energy Star lets you have twice the amount of total leakage than if you do a res check. So we're going to kind of get into, I guess, the strategies everyone's using to kind of undertake that.
The basic things is sealing all boots to drywall and the floors. That's going to become a standard for you. If you weren't doing that before, you need to do it now. All duct systems, connection joints need to be mastic. Some folks are using the mastic tape. It's extremely expensive. You're much better off with having your contractor get a big bucket of mastic. And they need to heavily apply it, not paint it. But I will tell you, the houses that have more flex tend to test better when it comes to air leakage because there's less joints.
Is whenever possible, get the entire ducts and mechanical system inside the thermal envelope of the house, then you don't have to do any of this stuff.
That's a big note, right? And I was going
And
to touch
that
on
would be the number one thing that I would do, and it significantly impacts the sizing of the equipment as well. So you say, why does he keep on hopping on sizing the equipment? It saves money. So if I get my duct system and mechanical system inside the building, I will save money and I'll have a more efficient house to start with.
And on that point, not only would you be exempt from the duct leakage testing requirement if you do that, if all the duct was in conditioned space, your duct leakage outside will basically be almost nothing, which means if you go through the performance pathway, you're actually going to get credit for a lot of that efficiency, and that's going to help you maybe back out specifications and save on hard costs.
We're trying to recommend all the systems installed in the conditioned space. I mean, that's kind of our number one initiative, is to see if we can encourage that practice to get away from these designs where the ductwork's in the unconditioned space. So that's kind of our number one strategy. The execution is really where we see the failures occur. I mean, we can only say so much on a drawing as to use mastic and meet the requirements, but if the contractor doesn't have the experience and walks into a job where he's never really handled a duct test before, I mean, they're gonna fail.
Duct leakage to the outside, that is a direct impact to your blower door test. So when we talk about trying to get down to 3 air exchanges, you need to make sure you're driving those duct leakage tests. Forget about 4%. If you can get it to 1%, you're helping your blower door test.
Does everybody get that connection? That's a key point, right, in terms of the approach? Because, I mean, it's connected, because it's
Yes.
leakage to the outside, so then the ductwork is from the ductwork and then to the outside of the envelope. So you can, I guess, sort of kill two birds with one stone in some aspects.
This is something that I always bring up to my clients in case you're kind of in this pickle where, let's say you're in a townhome product where 70-80% of the ductwork is covered in sheetrock, and you're trying to pass a final total leakage test. All of that ductwork within that sheetrock is affecting your total leakage test, and it could be cheaper to do this than to cut sheetrock essentially almost blindly in order to try to find these leaks. So Aeroseal, kind of the best way I explain is it acts like white blood cells. It clots openings in the ductwork, and it is a atomized polymer that's sprayed through the ductwork, not through the air handler, so it doesn't kind of gum up the coil in the furnace, and it's able to seal, I believe, any gaps, I believe, a 1/4 inch or less. So it's really able to do it as long as the ducts, aren't disconnected. It's able to kind of get the numbers down really below 1%. It does a great job, but it also will not seal the boots to the sheetrock. So that is another aspect that you're still going to have to do in order to kind of meet your, really it's all the air leakage test that can get affected.
We're going to talk about kind of issues in kind of disparities of enforcement, because obviously, in practicality, you have, I think a lot of the national builders take the position, from my perspective, of we're just going to be above reproach, we're just going to do what we know is right, and we're not going to necessarily always game this out. But you do run into issues where you'll have a code official who, in some communities, you're not allowed to use blown insulation in the attic, right? And that will then, this is sort of idiosyncratic incident where then you have to kind of change up your whole thinking because of, this sort of localized issue.
So the change from the previous code to the 15 now requires kitchen ventilation in the kitchen and also ventilation for the dwelling. So what we're asked to do now is to provide a solution for the kitchen ventilation, and you could use the range hood as the method. That would be the intermittent method option, which is 100 CFM. You can also provide an exhaust fan in the kitchen, which most choose not to do because of the unsightly appearance of an exhaust fan in the kitchen. And also the whole house system, that's a new requirement. So especially in the apartment buildings that weren't Energy Star, they didn't require mechanical ventilation. You could use the infiltration from the windows. But now the code is a mandatory requirement that ventilation is provided to the dwelling.
Mechanical ventilation is required. Balanced ventilation is not required in the code. An exhaust only or even a supply only is acceptable in the energy code.
Does anyone want to speak to what they felt was the most significant change when it comes to mandatory requirements, I guess, besides the mechanical ventilation component?
The air sealing, the 3 ACH
Yeah.
50, and the mechanical ventilation were the two big ones.
Does everybody know what a manual J, D, and S report is? It's a cooling and heating calculation. So you put the parameters of the building in the computer program, and it provides you a calculation on the heating and cooling requirements for the dwelling or structure. So we have to submit these Manual J reports along with the drawing package for the permit submission. We're not seeing the D being requested by the local jurisdictions as much. I imagine someday that's coming. The Manual D is the duct design, where you actually take your design on your plans and you input it into the program, and it runs a pressure calculation. It's been in the code for a while. However, municipalities, townships have not been asking for the calculation. It's coming. The day's coming soon. I mean, we do perform them as part of our design standard.
Yeah, but don't fall on the fact that if they're not asking for it, you don't need it, especially in New Jersey, because we all know that they have the authority to come back later.
The main takeaways, right? Work with the Rater for energy code. It could be us, it could be somebody else, but work with them from start to finish and use them as a resource. Topside Aeroseal, boots to the sheetrock. What are some other key takeaways you want to?
Mechanical ventilation, having that designed early on because it'll affect the loads, and you don't want to get stuck adding that at the end.
Richard, any closing thoughts?
As I said, most of this is the way things are carried out in the field. That, in terms of energy code compliance, that's the most critical, and quality control.
You guys want to go down the line, I guess?
Yeah, I would just say don't depend on your local code official really to be your resource here, because there's such an inconsistency. I've had inspectors that don't even ask me for final testing or ask me for any documentation. We do it. And I have others that as part of my CO process, when he comes here, I have to have the results.
I agree completely. Don't rely on your code officials to whether they are or not enforcing the code. It just occurred to me, I was sitting here thinking about this. You know, the final code hearings for the 2015 energy code occurred in this building. Yeah. How many building officials from the state of New Jersey were here when those code hearings occurred? 0. It's not something they had to pay attention to 10 years ago. And so they're in a learning curve as far as I'm concerned. And so, it's working with these guys as they become, and they're going to, over time, they're going to start becoming more stringent.
Yeah, I guess as a mechanical engineer looking at designs, I would say keeping the ductwork out of the unconditioned space is really something that I try to promote. The attic systems just waste so much energy.
I want to thank everybody for coming. I think the questions were great. I want to, if everybody could thank our panelists, I think they're all amazing.